All right, guys. So what we want to do today is keep going with what we kind of introduced yesterday. Again, and that's graphing. Okay, quadratics. Again, quadratics means you have x to the second power. And again, when we graph something that's x to the second power, we get a parabola. But again, I want to move away from the table of values. All right, that's the very basic way to graph. So we're going to graph using roots, which are our x-intercepts, our zeros, and of course using our vertex, the very center. You can think of it as the center of the parabola. So again, you guys know how it works. Copy down the title, stop it um, if you need to catch up. So let's jump into it. Again, here's our objective. Basically, again, like I said, the idea is if I give you something like y equals x squared plus 12x plus 32, if I ask you to graph this, well, you know it's going to be a parabola because it's a quadratic. It says x to the second power. Okay. Now, I don't have a table of values, so how do I graph it using the vertex and the roots? Well, I have to find the roots first. The way that we find the roots, the x-intercepts, is by using our Punnett square. And we factor it, we solve it. All right, in this case, I got -8 and -4 as my x-intercepts. Whoops, let me go back. Okay, and -4 as my x-intercepts. Well, that's kind of nice because the parabola has nice symmetry. So again, if I actually draw my axis of symmetry on this, I see that my vertex is actually right there. I know that it shares the x value, which in this case, my vertex, should be a v, is going to be here sitting in the middle between these two numbers. Between -8 and -4 is -6. It's -6 comma something. And how do I get that extra number? Well, you have to take -6 and you plug it back into where your x's were. If you see, I plugged it in, and I got -4. So we're down here at -4. All right. Now again, once you have those 3 points, it's very, very quick to sketch the left side, and it's very, very, very quick to sketch the right-hand side. So again, let's kind of look at that one more time. Um, how many points do we really need? Really just 3. And the special ones, of course, it's the center, which is your vertex. Once you have the two x-intercepts, okay, we can complete our parabola. In this case, it's pointing downward. So that's the basic idea. That's what we want to get out of today, being able to graph using the vertex and your two roots. All right. So let's jump into it. So here we see it says graph f of x equals -x squared plus 8x minus 12 using, again, roots, which is a fancy way to say x-intercepts or zeros, and then our vertex, the very center of our parabola. So let's, again, before I can get the vertex, let's take a look at the roots. How do we find the roots? Well, you have to set y, or in this case f of x, equal to 0. So you have 0 is equal to -x squared plus 8x minus 12. Okay, well, I know how to solve this. I can use, again, the Punnett Square quadratic formula. Well, I'm going to go with the Punnett Square. It's a little bit quicker, a little bit easier here. It's in standard form. There's no GCF on this problem. We'll actually get into those problems next week. So -x squared goes in the very, very first box. -12 goes in the last box. Now, you have to be careful here. How am I going to get a -x squared? Well, that's going to be a -1x. Remember, there's a 1 right here. And a just regular x. -1x times x will give us -1x squared. Now I need that secret combination. What two numbers multiply to give me -12 and also at the same time add up to give me that 8x here in the diagonals? Well, two numbers that multiply to give me 12. I'm going to go with 6 and 2 on this one. I could have also tried maybe 3 and 4, but let's go 6 and 2. I'm just going to put a 2 up here. Let's make it positive. +2, so this has to be a -6. Be careful with your signs. +2 times -6 is -12. That checked out. What's 2 times x? That's 2x's. What's -1x times -6x? That's +6x's. Well, 6x's and 2x's, when I combine those guys, guess what? They give me exactly what I needed, which was the 8x. So again, we're still not done. We actually, again, we have to solve. We have to find what x is. So we're going to set the top piece here, the -1x plus 2 equal to 0. This is applying the zero product property rule. And then on my side here, I have x minus 6 is equal to 0. Well, how do I solve these two guys? Again, it's just a basic multi-step equation. So we're going to say -2 minus 2. Cancels out. We get -1x is equal to -2. The last thing I have to do is divide by -1. Divide by -1. X is equal to 2. But again, because this is an x-intercept, I want to write it as an ordered pair. That's not just going to be x equals 2. It's going to be 2 comma 0. Now let me solve the other one because I do have two x-intercepts. I do +6, and I get x is equal to 6. And one more time, What is my second x-intercept? It's 2 comma 0, and that's going to be 6 comma 0. So make sure you guys label your x-intercepts like that. All right, so now that I have my x-intercepts, let's actually go ahead and scoot over and start to begin to graph. We're not going to be able to complete it, but we'll get the idea. So again, it's going to be a little difficult here for me. So I go over 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3. All right, so I'm going to scoot over and plot my two x-intercepts. So one of them is at 2, 0, so I scoot over 2, and I stay there. The other one is at 6, so I scoot over to 3, 4, 5, 6, and I stay there. I know those are my two x-intercepts. Okay, now I need to find my actual vertex. Now again, where is that going to be? I have to find the center to get my vertex. Well, let me draw my axis of symmetry. My axis of symmetry should be right in the middle. So if I scoot over 1, scoot over 1, scoot over 1, scoot over 1, I find out that my axis of symmetry is running right. That is the middle right there. What number is that? That's 1, 2, 3, 4. So I know my vertex, I'm going to use the letter V here, is sitting at 1, 2, 3, 4, comma, something. And I don't know what that something is going to be. Well, how do I find that exact? Is it 4, 1, 4, 2, 4, 3? You have to take 4 and you have to plug it back into your original function. So again, negative, instead of the x, I'm going to replace it with the 4 squared plus 8 times 4 minus 12. Well, let's go ahead and finish this, right? What is 4 to the second power? That's going to be 16. Now, this is the biggest part where students mess up. I told you guys, don't forget about that negative. That negative has to be brought down, turns it back into a negative 16, which is kind of strange, but it's the way that it works. What is 8 times 4? That's 32. Let me bring down the minus 12. What's this part going to give me? What's 32 and a minus 16? That's just 16. Well, 16 minus 12 is going to give me just 4. So when I plugged in 4 into my function, my output was also 4. So where's my vertex going to be sitting here at? It's going to be 4, comma 4. So I go right 4 to my axis of symmetry, and I go up 1, 2, 3, 4. And I place my vertex way, way up here. And check this out. We can complete our parabola. This is very difficult on the computer. And we go down. And there we have it. That's how we quickly graph a quadratic. Now again, to me, this is much, much quicker, much easier than having to go through a table of values. You have to do this process right here 5 or 6 times, and sometimes you don't even get the full parabola. All right, so what I want you guys to do, we're going to skip that part right there. I want you guys to take a second, okay, and I want you guys to try this on your own. Pause the video right here, and then we'll go through the process. All right, so let's go through this one. This one was on you. Let's start off by finding the roots. If we're going to graph this, let's find the roots first. So again, we set y equals 0, so in this case f of x. 0 is equal to x squared plus 4x plus 3. Now again, that's in standard form. There's no greatest common factor. So let's go into and take out our Punnett Square here. We're going to solve this guy by factoring. So again, solving means you actually have to find x, what x equals. X squared, that's positive 3. This is nice, this is easy. This is x, and x gives us x squared. Now, what secret combination gives us, multiplies to give us 3? There's only really one. It's going to be positive 1 and positive 3. Or you could have said negative, negative, right? So what do we get here? This is 1x. What about the other one? I get 3x's. Now, 3x's and 1x's, when I combine those guys, they give me the 4x's that I needed. All right, let's apply the zero product property that says that x plus 1, so across the top, I set that equal to 0, and I'm going to solve that to get my first x-intercept. The other one is going to be x plus 3 is equal to 0. Well, how do I solve both of these? Again, inverse operations, minus 1, x is equal to negative 1, minus 3, 3, x is equal to negative 3. And of course, again, these are our x-intercepts. So how should I write it? That's going to be negative 1, comma 0. And the other one will be negative 3, comma 0. Now let's go ahead. Again, we can't graph the whole thing, but it's going to help us to quickly sketch our two x-intercepts. So here's my y-axis. Here is my x-axis. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Why not? All right, so let's plot our two X intercepts. So one of them is going to be negative 1, 0. So we go left 1, and we stay there. And the next one is going to be negative 3, 0. So I go left 1, 2, 3, and I stay there. Okay, so now to find my vertex and complete this. So what I'm going to have to do here is draw my axis of symmetry. I need to find the middle. Well, that's kind of nice. The middle is going to go right through here. And again, where's my vertex actually going to be? I know it's on that axis of symmetry, but I don't know whether it's way up here, kind of down here, or further down. Well, I know that my vertex is sitting at, what is this, negative 1, negative 2. So my vertex is at negative 2, and again, comma, something. How do I figure out that something? You have to take negative 2. That's your input value. You have to input it into the function to get your output. Remember, this is a machine here. So let's take negative 2 in parentheses to the second power plus 4 times another negative 2 plus 3. What's negative 2 squared? That's negative 2 times negative 2, which is positive 4. What is 4 times negative 2? That's negative 8 plus 3. What is 4 minus 8? That's going to be negative 4. Negative 4 plus 3 is going to give me negative 1. So what is my output? When I plugged in negative 2, my output was negative 1. That is going to be the exact position of my vertex. So let's go ahead and go back here and finish this up. My vertex is at negative 2, so I go left 2 and then down 1 because of the negative. And there we have it. I have my vertex and my two X intercepts. So here we go. Quick sketch. Quick sketch. And there we have it. All right, guys. So again, the idea is you're using the Punnett Square. Careful with your signs. Biggest mistakes that I see again are always with this little sign. So watch out for that. And again, to get your vertex, find the middle. What's in between both X intercepts to get the X value of your vertex, and then you just have to plug it in only one time. It's not a lot of work. It's all right. You'll be fine. You'll live. And in this case, we got negative 1. Once you have it, yes, I do expect you guys to graph it. So this is what your class activity looks like today. All right, so let's scoot all the way over. Again, we can skip all this, give you guys enough time. Okay, so for your class activity, here it is, guys. This one is a challenge. You do not have to do number 6. If you'd like to, go for it. I can sprinkle a little bit extra credit. Don't forget, today is the last day that I will accept any late work. So if you do number 6, again, I can sprinkle a little bit extra credit if you really need it. So there you guys are. You guys are responsible for 1, 2, 3, 4, and 5. You are graphing using, again, your vertex and your X intercepts. All right, guys, have a nice day. Have a great weekend. I will see you guys on Monday.